Today we're talking about factoring trinomials. And just to give you an idea of where we're going here, remember before we had something like this, say x plus 1 times x plus 2, and we multiply all that out, and we end up with x squared plus 3x plus 2. Well, we're going to be actually going backwards this time. Instead of starting here and ending up here, we're going to start with a trinomial and end up with two binomials. So the trinomials are in the form of ax squared plus bx plus c, where a is always going to be the coefficient of the squared term, b is the coefficient of the variable by itself, and c is the number without any variable. So that's going to be our starting point when we go to factor something like this. We're going to define a, b, and c. So a, again, is the number in front of the squared term. B is the number in front of the variable, and c is the number without any variable. And so we're going to have sort of this procedure that involves this x right here. And in the top of the x is going to go a times c, and the bottom of the x is going to go b. So I'm just going to multiply a times c, which is 15, and b is 8. So we want to come up with two numbers that when we multiply them, we get 15, and when we add them, we get 8. So we're going to just list the factors of 15. So we can have 1 and 15 or 3 and 5. And as we can see, our only option for two numbers that are going to add to give us 8 is 3 and 5. So those are the two numbers we're going to put on the two sides of the x, 3 and 5. And those are the numbers we're going to use to write our two binomials. So our first one is going to be r plus 3, and the second one is going to be r plus 5. Now, if we were to multiply all of this out, we would end up with this trinomial right here. Okay, so we're going to go through this procedure again. And today we're only talking about when the a value is 1. We're going to be getting into a little bit more factoring next time. But for now, we're going to define a, b, and c. So a is 1. Again, that's the coefficient of the square term. B is the coefficient of x, and c is the number by itself. Don't forget to get that sign in there, that negative. So we're going to do this x again. This is going to be a times c up here. This is b. So a times c is negative 14, b is 5. So I'm looking for two numbers that when I multiply them, I get negative 14, and when I add them, I get 5. So I'm going to list out the factors of negative 14. So we see because it's negative, I need one positive and one negative. So I could have 1 and negative 14. I could have negative 1 and positive 14. And remember, I'm looking for when I add them together to get a positive 5. So I could have 2 and negative 7, or negative 2 and positive 7. And those are the only combinations that I can have to get negative 14. So the winning combination is going to be this one right here, because when I add the two of the together, that's going to give me a positive 5. So I have negative 2 and 7, and those are the two numbers I'm going to use to put in the parentheses. So I have x minus 2 times x plus 7. And that's it. We're going to talk through one more before you try one on your own. So here I have a middle term that's positive, and the last term, or I'm sorry, middle term is negative, last term is positive. So let's go ahead and put all the factors out here. So a is 1, b is negative 12, and c is 32. So remember, it comes up here, a times c. So I'm just going to multiply those two together, 1 times 32, and just b comes down here. And so now I'm going to list the factors of 32, keeping in mind that in order to get a positive when I multiply and a negative when I add, they both are going to have to be negative. So I can have negative 1 and negative 32. I can have negative 2 and negative 16. I could have -4 and -8. And that actually is going to be our winning combination, -4 and -8. Because when I add those two together, that gives me -12. So -4, -8, and that's what I'm going to plug in. So I have n minus 4 times n minus 8. And again, if I were to multiply all of this out using double distributive, I would end up with exactly what I started with. All right, I'm going to give you one to try, and then we're going to continue this discussion in class. So go ahead and try this one on your own, and we'll continue this in class. See you then.